In this video, we are going to talk about joint and partial variation examples. Now, we already have an example of a joint variation on the screen, so let's jump into it. I'll write out solution here. If I read out my question says A varies directly as B squared and inversely as C. If A is 0.54 when B is equal to 1.2 and C is equal to 2. Find A when B is equal to 2.2 and C is equal to 3.5. Now, one of the first things I want to do is to write out my given variation from the question. So the given variation comes from the statement A varies directly as B squared and inversely as C. For us to write this, we know that A varies directly as B squared can be written as this, and then A varies inversely means that there is a 1 over. So I can write times 1 over C here. So that when you put all of this together, this is written as A varies as B squared. Now if times 1 over C times B squared, you get over C here. Now, once you get the variation, the next thing you want to do is to convert this variation to an equation. How do you do that? You introduce a constant. So I'll say introducing constants. I could name my constant any letter, but preferably I like to use constant K. So that if I'm converting this to an equation, this becomes A is equal to, my K will be here, B squared over C. Now, before I even start solving my question, the first thing I want to do is to find the value of this constant. So I'll say for K here. Now, we are given information that can help us find K. We are told that if A is 0.54 when B is 1.2 and C is 2 here. So that's what we use to find K. First thing we want to do is to make K the separate formula here, so that if we have the equation as A is equal to KB squared over C. If you're making K subject to the formula here, the first thing we want to do is to cross multiply. So if I cross multiply this equation, I'll have KB squared is equal to AC. From here, I can divide both sides by B squared, so that this is divided by B squared, this is divided by B squared. This cancels out B squared, and then K is equal to AC over B squared. So to get the value of my constant, I simply substitute the values of A, B, and C here into this equation, so that my value of K is equal to, my value of A is 0.54 times my value of C is 2 divided by my value of B is 1.2, and then that is squared. So that my value of K is equal to, now for the numerator, if I have 0.54 times 2, I'll get this as equal to 1.08 divided by, for the denominator, if I have 1.2 square, I'll get this as equal to 1.44. Now if I have 1.08 divided by 1.44, this will be equal to 0.75. So now that I have my value of K, I'll pick this value of K and substitute it into this equation here, So that's my actual equation will be A is equal to, the value of K is 0.75, so this will be 0.75 B squared over C. So this is the equation that we use to solve any other problem that we're given for this question. Now my next thing is that I'm told to find A when B is 2.6 and C is 3.5. So for A, we know that our B is equal to 2.6 and our C is equal to 3.5. So that from our formula, we have A is equal to 0.75 B squared divided by C. We just substitute values of B and C into this equation. So the value of A is equal to 0.75 times, the value of B here is 2.6, so say 2.6 square divided by, the value of C is 3.5, so this is 3.5. Now for our A, we'll multiply all the numerators together here. So if I say 0.75 times 2.6 square with my calculator, I'll get 5.07. Now divided by, the denominator is 3.5. So 5.07 divided by 3.5. I'll get A as equal to 1.449 to 3 decimal places. So that's it for this example. Let's quickly look into another example of joint variation to help you get how to solve joint variation better. Now, this is the next example. You can try to pause the video and solve it yourself. Okay, so like we did before, we read out the question and try to interpret it. But before that, I'll write out my solution here. We're told that the kinetic energy E of an object varies directly as its mass and the square of its velocity. We are told that if the kinetic energy of an object with a mass of 2.5 kilogram moving at 15 meter per second is 281.25 joule, find the energy of the object with a mass of 1.8 kilogram moving at 20 meter per second. Now, the first thing we want to do is to find the variation relationship. So we are told that the kinetic energy, which is E here, varies directly as its mass. So to interpret that, you write varies directly and the square of its velocity. So we multiply a variable directly as the mass and velocity square, so that the energy varies as mass like this. The first thing we want to do is to make this an equation. So to make this an equation, we simply introduce our constant K. So introducing constant K, the energy is then equal to kmv square. Like I said before, the next thing we want to do is to find the value of K. So I'll say for K here, before we even start finding how to get K, we have to make K so vector formula here. So that this is A is equal to kmv square. So to make K solve the formula here, I simply divide both sides by mv square. So this is divided by mv square. This is divided by mv square. And then this cancels out this, so that K is equal to E over mv square. Now in the question, we are often given the relationship between each of these values, even without knowing our constant values. Now that relationship is that we are told that if the kinetic energy of an object with a mass of 2.5 kilograms moving at a velocity of 15 meter per second is 281.25 joules. So this is the information that we use. Now the energy we are given is 281.25 joules. The mass we are given is 2.5 kilogram. The velocity we are given is 15 meter per second. So that our value of K is equal to, the energy is equal to 281.25 joules divided by the mass is 2.5 kilograms times the velocity is 15 meter per second. Now the velocity here is squared, so this is square. So that for the numerator, I still have 281.25 divided by, if I multiply 2.5 times 15 square, I get 562.5. Now 281.25 divided by 562.5 is equal to 0.5. So now that I have my value of K as equal to 0.5, I pick 0.5 and plug it back into this equation, so that my energy is equal to 0.5 mv square. This is the equation I'll be using to solve every other question or this question. So the question we're actually told to find here is that we're told to find the energy of an object with a mass of 1.8 kilogram moving at a velocity of 20 meter per second. So that means we're finding energy. So I'll say for energy, we are giving the mass as 1.8 kilogram. So I'll say when the mass is equal to 1.8 kilogram and we are giving the velocity as equal to 20 meter per second. So that when the velocity here is equal to 20 meter per second. So that simply calculate the energy, we just plug in these values into this equation, so that the energy is equal to 0.5 times the mass is 1.8 times the velocity is 20. This means that energy is equal to 0.5 times 1.8 times 20. If we do that to our calculator, we get 18 joules. Remember, the unit of energy from this question is joules. So that was why I added joules as the unit here. So that's how to do joint variation questions. Let's jump into partial variation examples so that you can have a look at them. We already have an example on the screen concerning partial variation. So I'll simply write out solution here. We're told that the cost of taxi ride is represented with the letter C is partly constant and partly varies with the distance traveled. A ride of 22 kilometers costs $42.4 and a ride of 25 kilometers costs $47.8. Find the cost of a journey of 17 kilometers. Now, the first thing we do, like with before, is to write out our variation. So we are told that the cost of a taxi ride is partly constant. Now, what this simply means that we have C, since we have been told that it is partly constant, it is equal to, we go directly to our equation in this case. So this will be B. Since we are told that it is partly constant, that means this B is a constant value plus, we are now told that it partly varies. Partly varies means that we are dealing with a variable. So since it partly varies, we introduce another constant along with the distance traveled. Okay, so we say A, D here. So that A here is a constant and B here is also a constant. So whenever in partial variation we are told of anything called partly constant, our relationship would mean that we are having a relationship with a constant value. If we are told that it is partly varies, we are having a relationship with a variable. So like in this case, we are told that C is partly constant with B. So that C is simply equal to the constant of B and C is partly varies with D. So that C is varying with D and then we introduce a constant that goes along with D. Now the equation is simply C is equal to B plus AD. Now, the next thing we need to do is to find the value of the two constants. The two constants here is A and B. So I'll write for B and A. Now, to help us find the value of B and A, the first information we're given is that a ride of 22 kilometers costs $42.4. So I'll pick this equation and put those values inside. We know that when we have the distance as 22 kilometers, our cost is equal to $42.4. So that I'll write it out as 42.4 here is equal to B plus 22A. So we can call this an equation. Let's call this equation 1. Before we continue, let's clean up this space. For the second information we are given, we are told that and a ride of 25 kilometers costs $47.8. So I know that when my ride is 25 kilometers, my cost will be $47.8. So if I put this into this equation, it becomes 47.8 is equal to B plus 25A. Now I can follow this equation 2. Now the first thing I want to do is to bring the two equations together. So I rewrite equation 1 and 2 here. So this will be 42.4 is equal to B plus 22A. Now this is my equation 1. If you remember, my equation 2 is 47.8 is equal to B plus 25A. Now there are several methods I can use to solve this. I can use two methods, the substitution method or the elimination method. But I'll be using the elimination method here. Now the first thing I'll do is to eliminate one of the variables. So for me to be able to eliminate any of the variables here, I have to make sure they have the same coefficient. What do I mean by the same coefficient? If I have 2b and 3b, the coefficient of this b is 3, the coefficient here of this b is 2. So they do not have the same coefficient. But if I have 2b and 2b, the coefficient here is 2, coefficient here is 2, so they have the same coefficient. The first thing I want to look at in my two equations is that, is there any of the variables that have the same coefficient? Now the variables I'm talking about here is simply b and a. So if you notice, b here is 1b and b here is 1b. So we can go forward and eliminate b. To do that, I'll simply subtract one equation from the other. So that's this would be like this. So substituting equation 2 from equation 1, I'll say 42.4 minus 47.8. This will be equal to minus 5.4. And then this is equal to, here I have b minus b. B minus b is simply equal to 0. Here I have 22a minus plus 25a. That is still minus 3a. Can say this is minus 3a is equal to minus 5.4. So that if I divide both sides by minus 3, dividing here by minus 3, this cancels out this. My value of a is then equal to minus 5.4 divided by minus 3. If I did that with my calculator, I'll get 1.8 as a. Let me clean up the space. Now for my value of b, I can pick any of the equation and use it to find value of b. So for b, I'll simply say from equation, I can pick equation 1 or equation 2. But let me pick equation 1. So equation 1 is 42.4 is equal to b plus 22a. To get my value of b, I simply make b subject to formula here. So that b is equal to, if I move 22 to the other side of the equation, becomes 42.4 minus 22a. So that b is equal to 42.4 minus 22 times. Now the a value is 1.8, so this is 1.8. So that's b is equal to 42.4 minus 22 times 1.8 is 39.6. So b is equal to 42.4 minus 39.6, 2.8. So I have the value of my two constants now. The first constant is b here, which is 2.8. The second constant is 1.8 here. I'm ready to plug these values into my equation. This is my key equation from the beginning, so this is where I'll be substituting it into. That means the value or the cost of the taxi is equal to the value of b is 2.8 plus the value of a is 1.8, then times the distance. So this is the equation we use to solve any other problem under this question. Let me clean up space so that we can continue solving the problem. Now, the question asks us to find the cost of a journey of 17 kilometers. So what we are simply finding here is that we are finding C when D is equal to 17 kilometers. So how do we find C when D is equal to 17 kilometers? We simply use this relationship here. So that C is equal to 2.8 plus 1.8D. So that the cost will be 2.8 plus 1.8 times the distance is 17. So 17 kilometers. So that C is equal to 2.8 plus 1.8 times 17 is 30.6. So 30.6 plus 2.8, we have C is equal to 33.4. Now the cost is given in dollars. So we know that the cost is $33.4. So that simply tells us the cost of this our journey for 17 kilometers will be $33.4. Let's look into another example under joint variation before we wrap it up. Now let's look into another example under partial variation before we wrap everything up. For this example, you can pause the video and try to solve it yourself. But before I solve it here, I will simply write out solution here. Like we've been doing before, we write out the relationship for the variation. So we know that P is the sum of two numbers, one of which varies as X and the other which varies as the square of Y. So we know that P here varies as X and sum of Y. We write this directly as equal to, if it varies as X, we introduce a constant along with X like we did in the other question. So that we can say the constant here is AX. The other varies as the square of Y. So Y is also a variable here. So we introduce a constant along with Y. So BY square. Now the constants here is B and A. And the variables here is Y and X. The next thing we do is to find the constant. So for constants, A and B. Now, from the question, we are always given information that can help us by find A and B. For the first time, we're told that if P is equal to 14, when X is equal to 3 and Y is equal to 4. So that we know that when P is equal to 14, X is equal to 3 and Y is equal to 4. Simply plugging these values into this equation here, so that we have 14 is equal to, you bring in the value of X here, it becomes 3A plus the value of Y is 4. So this is 4 square times B. So that if we do this, it becomes 14 is equal to 3a plus 4 squared is 16b. We can say this is equation 1. The second information that we're given that can help us find the value of a and b is that we are told that p is 14.5 when x is 5 and y is 3. So we know that when p is equal to 14.5, x is equal to 5 and y is equal to 3. So that if we substitute all of this into our equation, we get 14.5 is equal to 5a plus y is 3. So we have 3 square here. If we do this, we get 14.5 is equal to 5b plus 3 square is 9. So we have 9b. We can call this equation 2. Now, like I did before, we collect the two simultaneous equations together. So the first equation is 14 is equal to 3a plus 16b. And then second equation is 14.5 is equal to 5a plus 9b. This is equation 1. This is equation 2. Now, like I said before, we have two variables we are dealing with in these two equations. The variables are b and a. Remember, we can use the elimination method or the substitution method. If we're going to use the elimination method in this case, if we have a and b, we check whether the coefficient of b is the same for any of the equations and the coefficient of a is the same for any of the equations. So in this equation, if we check it for coefficient of a, the coefficient here is 3 and the coefficient here is 5. So we cannot eliminate a. If we check for b, the coefficient here is 16 and the coefficient here is 9. They're not equal to each other, so we cannot eliminate b. But we can do something. We can choose whether to eliminate a or b. So in this case, I choose to eliminate a. So if I choose to eliminate a, watch what I will do. Now the coefficient of a here is 3. So I'll use the coefficient of a here to multiply this equation. So that will say times 3 here. And the coefficient of a here is 5. So I'll use the coefficient of a here to multiply this equation. So this will be times 5. The point of doing this is so that the coefficient of a here be equal to the coefficient of a here. So doing the multiplications now, if I say 5 times 14 here, I'll get equal to 70. And then this is equal to 5 times 3a here is equal to 15a plus 5 times 16v is 80b. So this equation, I can call it equation 3. For equation 2 here, I can say 3 times 14.5. This will be 43.5. And then this is equal to 3 times 5a is 15a plus 3 times 9b is 27b. I can call this equation 4. Now, if you notice something about equations 3 and 4, my a values have the same coefficients. So what I'll do is that I can simply subtract one equation from the other. Now, if you're having trouble understanding the elimination method, I'll leave a link here so that you can watch a video on it. So that here, if I substitute equation 4 from equation 3, I'll get, if this would be 70 minus 43.5. 70 minus 43.5 is equal to 26.5. And then this is equal to 15a minus 15a is 0. 80b minus 27b is 53b. So that I have 53b is equal to 26.5. If I divide both sides by 53 divided by 53 here, my b will be equal to, this cancels out this, 26.5 divided by 53. My b value will be equal to 0.5. So from here, I can pick any of the equations to get my value of a. So I can pick equation 1, equation 2, equation 3, equation 4. I'll go with equation 2. But before that, let me clean up a bit of space. So from equation 1, my equation 1 is simply 14 is equal to 3a plus 16b. So what I'll do now is to make a subjective formula here. So making a subjective formula here, I'll move 16b to the other side first, so that I have 3a is equal to 14 minus, if plus 16b is going to the other side, it becomes minus 16b. So this is minus 16b. Now to make a subvector formula, I simply divide both sides by 3, divided by 3 here. This cancels out. This a is equal to 14 minus 16b over 3. Let me clean up space. My value of b is 0.5, so that this will be a is equal to 14 minus 16 open brackets. Remember, b is 0.5, so be 0.5 divided by 3. My a is then equal to 14 minus 16 times 0.5 is 8 divided by 3. 14 minus 8 is equal to 6 divided by 3. Now this means that a is equal to 6 divided by 3 is 2. So I have my value of a now and I have my value of b. The next thing is to plug both of them into this equation. So let me clean up space before I do that. So that the equation I'm looking at here is p is equal to ax plus by squared. If I plug my a value and my p value into this equation, comes p is equal to 2x plus 0.5 y squared. 0.5 is also 1 over 2. So I can write it as p is equal to 2x plus 1 over 2 y squared. So this is the equation I will use to solve whatever problem comes under this problem. Now, after this, we are told that we should find p when x is equal to 4 and y is equal to 5. So for p, when we have x is equal to 5 and y is equal to 4, we have p is equal to 2 open brackets, x is 5, we plug it directly, plus 1 over 2 times y is equal to 4 is 4 square here, so that we have p is equal to 2 times 5 is 10 plus 4 square is 16, so this is 16 divided by 2. Now this is equal to 10 plus 16 divided by 2 here is 8, so 10 plus 8 is 18. So we know that p is equal to 18 when x is equal to 4 and y is equal to 5. So that is how to solve joint variation and partial variation problems. If you like the video, leave a thumbs up and I hope you learned something. Share with your friends and subscribe to the channel. Thanks for watching.